Greetings, everyone. Good afternoon, good evening. My name is Kanisha Patterson. I am a Nashville, Tennessee / Columbia, Tennessee native, and I am recently traveled to Atlanta, Georgia. So I now am in Atlanta, Georgia, working in tech. So today, I just want to lay a few ground rules for joining in on this meeting and for what's to come. So once you join, again, please mute your mics. If you have any questions, you can either you have two options for posting questions. So you can post your question in the chat window, or if you would like to step up to the stage and ask either myself or Warren any questions, be sure to raise your hand with the features that Google provides us below. And we will be sure, I as your moderator, will be sure to take a look at that. We also have Glenn Dixon and Tony Fletcher who are assisting in the chat. So you can add either one of them or myself. And we'll be sure to take a look at the hands that are raised and get you called up so you can address any questions that you have on the stage. Other than that, just be sure, when you ask your question and you are on the stage, be sure that you're mindful of how much time that you're spending in your question. We are going to be timing. We're going to give you about 3 minutes per question and that back and forth response. So just be aware of your questions and your time to respect other people's questions that they may have. So that being said, that's the ground rules for the evening. Again, just be sure you're muted when you're joining in or while Warren is talking. So without further ado, I do want to introduce everyone to this meeting and to this webinar. This is titled A New Dimension in Data, an Introduction to Vector Databases, given by Warren Sadler. Warren Sadler is a Nashville, Tennessee native. And to my knowledge, I've just learned that he is also an HBCU graduate of the Tennessee State University. So go Big Blue. Warren Sadler is also a Chief Technology Officer at Therify, which is a mental health matching company for Black and Brown people. It is a wonderful app. I've actually had the opportunity to speak with Warren about this app and understand some of the inner workings of it. Amazing. Please take your time to look into it and see what it can offer. But again, Warren continues to support the Black and Brown community in Nashville and beyond. Warren has, with the Black Codes ourselves, continuously posted and helped others with any coding questions that they have, provided knowledge of his experience in the industry, and the list goes on. So without further ado, I'm going to go ahead and hand this off to Warren. And again, thank you so much, Warren, for joining and providing this overview of vector databases. So thank you again, Warren. I'm handing it to you.
Thank you. Thank you for the gracious intro. Yeah. Now I just got to live up to it. And so this is where it all falls apart. But I'm going to share my screen and we'll jump on in. All right. Can everybody see my screen there? Oh, great. So, like Kanisha said, this is an intro to vector databases, a new dimension in data. Honestly, this is kind of a Trojan horse talk. There's a little bit more to it. I feel like I can't help but talk about also some of the really exciting things happening in the AI and ML space. And so in this talk, we'll actually cover a few things. I'm going to get my screens correct. There we go, so I can still see you guys. Ask some questions. But let's do a quick run of show what is going to be discussed. And so we're going to do like a little speed run, AI, ML. I'm not sure everyone's familiarity and background, but I think it's important that we all have that sort of shared context between sort of these concepts. We're going to do a demo of LangChain, a really exciting Python, TypeScript, there even is some Java work going on too, depending on everyone's sort of stack, to interact with LLMs, large language models. We're going to talk about what that is, really understand what's going on there. And then of course, Q&A. I think I really appreciate just dialogue and discussion. This is a presentation, but like Kanisha said, you can raise your hand at any time. I think things tend to flow better when we can have that open discussion. And I think we really get to the meat and potatoes of things when people can ask questions the way that they see it. But let's dive on in. So a little bit about me. Like Anisha said, I am the CTO and co-founder of Therify, a mental health company where we use all sorts of technologies, primarily day-to-day. It's like TypeScript, JavaScript is the application. In fact, I think Jesse Wooten is on here. He's my principal engineer. And so, you can ask him how it actually works. But before that, I worked at McKinsey & Company as a cloud consultant, helping companies, organizations like the Fed really adopt cloud technologies, so things like AWS and Azure. Before that, worked at Assurion as an engineer helping them develop their authentication service. For that, engineering manager at Lonely Planet, one of the larger travel publication companies in the world. Really cool if you guys go to bookstores. They're still around. You go to bookstores and you look in the travel section, you'll see these travel guides from Lonely Planet. They actually had some pretty cool software on the back end. But the thing I'm most excited about, where a lot of this love for AI, ML came from, was my time as a data science engineer at HCA, Hospital Corporation of America. It turns out Tony and I are both alums from HCA, good place, great company. But data science is used there primarily to help people have great clinical outcomes. One of the things I worked on while at HCA was a machine learning model that could predict sepsis. And if you guys are familiar with sepsis, it really is an infection where your blood basically turns against you. So imagine your entire body being just like seized, unable to even process anything, because blood's how we work. And so high morbidity, so it always ends in death unless it's caught. And so we helped develop a model that did just that, 48 hours in advance of the first clinical indication, just using data coming from hospital systems. So really exciting stuff. Some of the possibility of AI and ML. And so excited to sort of share my understanding. I'm by no means a master in this stuff, just a practitioner. But I think that's, if anything, the goal. Glenn sort of said his vision for this was people walk away inspired and excited about what's possible with technology like AI. And so I hope we can do some of that, really just be a foundation for how these ideas and concepts work. So let's do it. One thing that I think is always worth distinguishing is what is the difference between AI and ML. It's almost like JavaScript and React. You almost can't have React without JavaScript, right? AI really is this field of study trying to approximate and understand human intelligence, right? From a machine's perspective, can a human being, our understanding, our intelligence be emulated by a computer, which is pretty exciting. ML, machine learning, I even have these terms just so as I'm speaking to it, you can read it. ML is the programming of computers using statistical models, right? Probabilities, so that computers can make inferences on data they haven't even seen yet. And so I don't know how much, I know a few faces in here, programmers. You guys know what it takes to actually make a computer make a decision. You have to write that logic, you have to write that condition, those Boolean expressions. Well, AI and ML gets us in a place where we're not thinking about that. We're more or less giving a computer examples of data and saying this is the right outcome. And then from there, it can learn using statistics, using probabilities to make inferences and predictions on that data. So pretty exciting. So just to be clear, again, AI is the broad field of study, right? This goes back to the 1950s, though we're seeing a lot of super exciting things today, like ChatGPT. This is an old field of study. ML is the actual practical application of that using probability, using statistics to create computer programs that can learn from data. Okay. And so some useful terms you'll hear thrown around. Model. A model is the outcome of actually creating and coding a probabilistic system. The model is the thing that you give data to and it gives a result. So ChatGPT, that is a model. It takes an input and it gives some sort of response. Training data, the data the thing's been trained on. Probability, you guys know about flipping a coin, 50-50 chance. These are the useful terms we sort of hear all throughout this talk. Just thought it was meaningful to give. Again, we're sort of speed running some of these terms. So when we get into the demos, we'll have a shared understanding. But let's dive into some more things. So I think the recent star, the thing that everyone's super excited about is ChatGPT. And what does that GPT stand for? We'll actually talk about really how these things work under the hood, but it stands for Generative Pre-trained Transformer, right? And so why transforming? Well, we'll talk about that in greater detail too. But essentially, computers don't have any conceptualization of the world as we see it. We have eyes, we have a whole list of like things that we just consume information with, and we make sense of it. Our brains are incredibly complex. Computers almost have none of that, right? What are computers thinking? They think in ones and zeros. So how do you take really complex information and make it something accessible to a computer? ChatGPT is doing just that, but on what's called unstructured data. Unstructured data. So again, we have programmers in the house. You guys are used to databases, things like PostgreSQL, MySQL. This is structured data. Everything has a column that has a name, but text doesn't have that. Text is unstructured. It could be anything. Images, songs, these are unstructured data. And so ChatGPT is really, really good at taking all of that messiness and making something very concise. And so when we say generative pre-trained transformers, it's this ability to take information that is unstructured, make something organized that a computer can reason about. And then really what ChatGPT is under the hood is what's called a large language model. Large language models. And so it's kind of an astounding fact, but ChatGPT, GPT-3, has been trained on the entirety of the internet up to 2021. So let me run that back. Everything that the internet contains, this thing has seen up to the year 2021. Just for context, on a single CPU, that would take over 355 years to train all of that data. But they can train ChatGPT, and of course, OpenAI, the company that created ChatGPT, can retrain it in a month now using a lot of their technology, using their tools. And so when you use ChatGPT, when you actually use the product, what you'll see is that you can give it any sort of text and it can reason about it. There are people who say that MBA level lawyers will be losing their jobs because this thing is so good at generating text that would stand up in court, because it's literally seen almost everything, like I said, from the dawn of the internet to 2021. But we'll talk about how it can learn new things, how it can be brought up to date with information that we have, and we can use it to actually answer interesting questions about our data. That's pretty neat. So how do large language models work? Well, we use them every single day. If you texted someone today, and you probably saw these little messages here at the bottom, this is predictive text. And so large language models, having seen loads of text, can make inferences, make guesses on the next word to appear. It sounds crazy that something as powerful as ChatGPT, all it's doing is looking at a sentence contextually and saying, what is the most likely word to come next? And that's it. How does that work? We'll talk about some of the cool things it's doing under the hood further, but that's essentially it. And so if I had to say at a high level, how do these large language models work? It's literally looking at the next word, and we as programmers know, if I can solve the small problem, I can solve the big problem. The small problem is, what is the next word? And that's what LLMs are doing. And so an example of this is the codes. Anyone want to guess some sort of 5-character word? What might that be?
Black.
Black. Okay, solid guess. Does it help if I do this? I mean, the answer is, of course, the black codes, right? But see how fast he did that. I mean, it helps that he found it the thing, but still, you know, it's still impressive, right, that we can do that. But now imagine, how would you teach a computer to do the same thing? Okay, so let's try another one. Anyone want to guess what this is? Anyone want to guess what this is?
Like a mask.
A mask? Looks like a subnet mask?
Yeah, a little bit.
Okay. What about now? Any of the web developers in the room?
It's a hex code.
So, okay. Now do we feel really strong about it being a hex code? Yeah. Okay. But that idea, this notion, what Tony did, what you guys are doing, what we call in AI and ML is this concept called encoding. Encoding, where we take data and we try to represent it in a way that is efficient for transmission and storage. How would you take something like the color red? Just try to solve that problem yourself, and you think through it. And I do this all the time with programming. It blows my mind. It's like I would have never thought when I was trying to make a a color system to say, you know what, we're just going to break it up into like 6 digits, numbers and letters, and this is going to be red. But it works, right? This is great. This is phenomenal. The fact that with programming, we can take ones and zeros and represent everything from this phone call to this presentation to colors on a screen is phenomenal. And that's what we're doing with AI and ML. It's the same thing, putting text, unstructured data in a format that the computer can understand. But one thing that these models do, this next level, which Tony did so quickly, you guys did so quickly, was apply context to that data, right? Because again, subnet mask isn't wrong. Whoever in the room who has the network chops, that's legit. This works. This could be a subnet mask, but context is everything for that data, right? So if you use RGBA in like Web 2, you don't necessarily have to use hex. This becomes red, right? But a subnet mask, this is wide open and then no wide close. And that makes sense, right? But context is key in that regard. And so we understand now a little bit how language models work, right? There's some aspect of encoding so we can get numbers and numerical values out of it. We have some sort of probability, so we're trying to understand really the next word that's occurring, and we need some way for the computer to actually have context, right? How does this stuff actually work? How does it all come together? Well, we also need ways of storing this data. This is where we get to find the meat and potatoes of sort of like vector stores and vector databases. Here are examples of some of the companies. Crazy thing, aside from Redis, Pinecone was actually founded in 2019. Chroma is really an open source project taking really what is vector storage. We'll talk about what that is shortly. And this happened just 2021. And these companies, Pinecone raised $100 million just this past quarter to work in vector databases. And we'll talk about again what they are. But this is how fast this stuff is moving. I think when people saw OpenAI, ChatGPT, it's one of the fastest growing products of all time. Over 3 million users in less than a week have signed up to use that product. It's the fastest product to ever be adopted, just period. That's how fast this stuff is moving. And technology is even going faster at this point in time. And vector databases play a role in that. But again, the role that they play is context and memory. So what do? Vector databases are all about finding similarity in text, right? They use the same thing, probabilistic models, and create these things called embeddings. Embeddings, we'll actually see what embeddings are here in a second. And what they do is they actually create what's called semantic relationship and probabilities on the relationships between words. This sounds really highfalutin, but all it is basically is saying, if someone were to ask a model, what is the capital of Tennessee, right? There's a lot of thinking the computer has to do. One, it has to understand contextually what you're asking. So we'll see in a little bit how you actually train a model. If you guys have used ChatGPT, you are aware that it has this concept of prompts. Prompts are the context that the model needs to understand your question. With that, it can then interpret your question and actually make inferences on that, actually compare that to other things and find what is the most probable answer. What's interesting, I don't have a slide about this, but this is just because I think it's super interesting. Did you know that they say chat models can do that? They can hallucinate. Chat models can hallucinate. That blows my mind that they're using that language, hallucination, right? Because what a model can do, I had a slide, I was thinking about it, but I think it's better to talk through it. What do we know to be fact, right? What is fact? What is something that we know to just be undeniably true? 2 + 2 is 4, that's a fact, right? What's possible with these models, because we haven't quite found a way to encode expression of just a statement from fact. So the models are capable of being wrong, confusing something that is just a statement with a factual event. So if a model is trained on something that says, well, you know, Tony went to the store yesterday, is that a matter of opinion? Is that a matter of record? Or is it fact? Hallucination is when the model thinks based upon its training data, it knows an answer to a thing, but that is not factually true, right? We'll talk about how you can sort of avoid that and code solutions to prevent the model from making guesses, right? When it doesn't know something. But that notion of a model confusing a statement with fact is called hallucination. I thought that's such an interesting way of describing these models and the way they make mistakes. But let's look at some examples here. Let's actually dive into, I have a slide about LangChain. We'll talk about, but we'll just probably dive into some of the demos here actually. And so large language models and LangChain again, like I said in the intro, really is a framework in Python and TypeScript. We'll actually do some live coding in them because, you know, it's the black codes, we got a code, we just can't talk about it. But what LangChain does, what it allows us to do is take documents. And so when we say unstructured data, what we mean actually are text, PDF files, tweets. You guys use Notion. You use Google Drive, S3 buckets. They can take any of this unstructured data, whatever format, and create what are called embeddings. And just like we saw with the color red, right? What is an embedding but some sort of numerical representation of data? You don't actually have to write that code any longer. That used to be a very complicated part of training models, is actually writing something that did the embedding. Using OpenAI, you can just give it your unstructured data and it'll generate embeddings for you. LangChain does this. Behind the hood, we'll see that it's like not even a line of code. You need to write code to actually generate embeddings. You just give it your data. And then how do you ask questions of it? Well, once you have your embeddings, that is stored in what's called a vector store. And what is a vector? I'll take you back all the way to like high school math. But a vector is just 2 points on a plane, right? An X and a Y. That's it. And why are X and Y coordinates important? When we talk about the distance between a thing, right? You guys remember our good old friend, man, it's taking me way back, way back. This is called Euclidean plane. This is the x-axis here, x-axis, and this is the y-axis. And this is already, you could argue, a form of encoding, even just this idea. Because we're taking really what are this idea of like two-dimensional planes. When you guys play Mario, you're describing, when you actually write a game like Mario, you're describing this character moving across 2 dimensions. Mario can move up, that's the y-axis, or he can move left and right, that's the x-axis. And so you're able to, with just these 2 little bits of data, describe where Mario can be anywhere on a screen. That's encoding. We're encoding his location, right? And so, have you guys ever coded collision detection? What is collision detection? Well, looking at 2 points on a plane and saying, do they overlap? This is an expression of distance. What is the expression of distance but literally subtraction, right? What is the difference between 5 and 10? It's 5. That's distance, right? It seems crazy that some of these very, like, it seems juvenile rudimentary concepts are the same underpinnings that make vector databases, some of the most powerful technology we've seen today, work. And again, like, this is where I get fired up. I get super excited about it, because I think oftentimes, particularly our culture, we're taught that math is this foreign thing. We can't possibly learn it. But some of these concepts, they're as basic as stuff that we learn in grade school. But I think there's often this misconception that we can't learn it, but we absolutely can. And I think us learning some of these concepts is how we make change and really good things. But I'll give my little soapbox. We'll get back to the demo. But that's really what a vector database is. It really is a technology that's really fast at taking these embeddings. And when I say embeddings, it's not just a data point, 2 data points of, like, we were to actually map these or make a definition of this. So this is like a high on the low on the x-axis, high on the y. And name these points, right? On x on the y, right? These are 2 data points. We could store this in an array. This could describe the relationship between things. That's just 2 data points. A vector database is actually storing literally hundreds of thousands of these data points in multiple dimensions. The dimensionality, basically, when we say dimensionality, this is a 2-dimensional grid. High dimensionality could be hundreds of thousands of things. So imagine you're trying to, like a computer, understand the Bill of Rights. Well, it needs to understand, well, when was it written? How could I encode the time something was written? So I could literally make a number representing from the dawn of time to now. That's, I don't know, Unix. You could just encode that in 1s and 0s, but I can encode every single word or statement in that document. I need to represent that textually. And an embedding is just that, okay? And so that's really all that's happening there. So once we have our embeddings, what we can do is use a pre-trained large language model, right? We talked about, again, what GPT is. It literally is that. It's a pre-trained model that's been, like we said, been trained on all the language in the internet from since the dawn of the internet to 2021. Blows my mind, super cool. We can plug our code into that and start to use it to answer questions about our data. And LangChain lets us do all of that. There are particular formats that these systems expect: a question, or what are called prompts, and then an answer, which is also just a text message coming from the bot itself. And so really, let's just say at a high level, pre-training, we take documents, we generate embeddings, we store it in a vector store. And then when a user wants to ask a question, it's actually the same thing, just in reverse. The question comes in, it's actually being used in the same model to generate embeddings, and then we're comparing that embedding against the vector store, and we get our answer. And that's really it. But let's see that in action. Let's actually use some code, because, man, I'm sure that's why we're here. We're here for the code. Maybe quick show of hands, Python folks. You raise your hand in the chat and app. Okay. Here we got one Pythonista. TypeScript, JavaScript, folks. You want JavaScript familiar? Okay. JavaScript. And then we gotta do the JavaScript. Sorry, my dog is he's on patrol right now, so you guys hear some barking. He's just making sure we're safe. So that's all that is. You guys see this all right? I can change the theme. Maybe something. I want to do too bright, something we can all see. This is an empty repository. We do have these same code examples that we're going to talk through here already in a repo that you guys can pull and peruse at your own leisure. This is more like a live coding, maybe mob programming. We're just gonna do the thing. We'll talk through it. And so this is going to be a TypeScript project. This has already been initialized with a package JSON. So I'm going to use Yarn add LangChain, OpenAI, install some depths. Glad my Antioch internet is fast right now, so we don't have to wait too long. I need to use the right node version. One thing to note about this, to verify, we kind of use like node 14. We're not on LTS right now, but LangChain is designed to use the latest and greatest node, so long-term support. I use NVM, so if you follow along with the repo, and in fact, let me just go ahead and share that link in case folks want to just browse the code while we look at this. 1 second. And while I grab this, any questions so far? Any thoughts? Has anyone used ChatGPT, messed around with it any? Anything they want to share?
There's no questions in the chat.
We have 2 people who've raised their hands. So Eze Amadi, did you want to? Oh, you just dropped your hand. Did you still want to ask your question? You can always post it in the chat if so. But we've got Jaricia, who's got her hand raised. If you'd like to come to stage, Jaricia, join in.
I was just trying to say that I did use ChatGPT before, but I didn't have any questions.
Okay. Man, did it kind of like, does it like trip you out like sometimes? Because sometimes the answers are like, that's wild, you know? Sometimes the answers are just like, how did you do that? Other times it's just kind of whack. It's like, man.
Yeah, I use it every day, and I've found most surprising when it does something I already know how to do way simpler or way more elegantly, and I feel kind of silly, but it's delightful.
Man, delightful. That's such a, you know, I think like technology, it has this potential to delight us. And ChatGPT, when people talk about why it's been so, explosive in its use, I think that's it. There's something so surprising about typing in a question and getting not only a good answer, sometimes a really sophisticated answer. Like, I don't even know if I could say it like that. And this is a computer that's just been trained, I guess, on the sum of knowledge of all of us. It's pretty cool. Woo! Big T Fletch, you got me, man.
No, I actually used it to help me come up with my mission statement for Social Dog, because Social Dog has like several moving pieces. So I was struggling for like weeks trying to come up with the best mission statement. And so I gave it to ChatGPT, and it gave me like 5 different ways to say it. And so I just grabbed pieces from it and then continued to diss it down. And now I feel like I've arrived. So it was a beautiful, beautiful process.
Gosh, like, I mean, I think about the applications of it. That's what's exciting, right? Where I don't know if you guys write emails for a living. Sometimes it feels like that's what I do. I'm just like, let the robot just write the emails. I don't want to write no emails no more. You know?
Oh yeah.
That's what I'm excited about.
Warren, I've got just a few more questions for you before you jump over into coding again. One question comes from Dooley. Dooley asks, is it true that it has access to the net now? So I'm assuming that, I don't know what you're meaning by that, Dooley, but is it, access to more recent data that you're asking about?
Yeah, and so LangChain actually has an illustration. Woo! What is LangChain made of? The most exciting part is this notion of agents. Agents. So agents are things that once the model has made a decision, first of all, that sounds crazy to say a computer is making a decision, but once it's made its decision, right, it can use what's called an agent to actually act on things, such as, I actually need to search Wikipedia for this answer. So yes, ChatGPT is plugged up to the internet. It can use an agent to go search for answers. Okay, I just got it because we're talking about it. I saw I was doing this today. I'm so hyped on this one right here. Because I was talking to my co-founder about it. And what they've created here with agents is this ability. Let me just give a trivial example, and then we'll dive into the code. We'll actually create some stuff with it. But this is the LangChain docs. This is the Python version, but it's not too crazy. Let's see. They have the, you know what? Let me search the sales agent. So, yes. Okay. So this is in this code, it's pretty phenomenal. I don't know if anyone actually does sales, but what they've described here is a model that's been trained to run sales. In other words, it can answer questions. It can introduce itself as a salesperson in an email. It can qualify the prospect, say, are you suited to buy? It can present the value proposition. It can do a needs analysis through question and answer with the prospect. It can present a solution based upon the person's particular needs. It can handle objections. This is a model that being trained simply with prompts. In other words, you don't have to code. And this is really the most exciting part about this. You don't have to write code that does this. You can write in plain human language these instructions to the model, and it'll act accordingly. Let me give you an example. So this is the prompt. So we'll talk about prompts here shortly. But basically, models are trained on prompts. And so it's saying, hey, model, you are a sales assistant helping your sales agent determine which stage of sales conversation the prospect should be moved to. No one's coding anything. We're getting to a point where like the team lead on your team who can't code can just write the instructions and the bot will write the code for them, which is pretty exciting. I need you to determine what phase you're in. It numbers the phases. And then they go further to say, let's see, for example, it's more of the data structure. Yeah. They said, hey, bot, your name is Ted Lasso. You are the business development representative. The name of your company is Sleep Haven or Social Dog, right? And Social Dog or Sleep Haven is a premium mattress company. And literally all the model does is it takes questions and it answers. And this can all be wired. So when we say agents and why sort of the connected to the net, Lou's question, why it's super exciting is if the model doesn't know, you can actually, and this is the chain and LangChain, you can connect it to other chains that can then go, I don't know the answer for that. Is that answer online? Let me ask myself, can I search this? And it'll go search the internet using the question it can't answer, incorporate that answer back into its response, and answer the question. So even if it doesn't know something, it can add something to its knowledge and answer a question, which is super exciting. So that was a super wound about way of saying, are they connected to the net? They absolutely are. How they are through these concepts or these things in LangChain called agents that can take a prompt and say, I don't know how to answer this, but I have an agent that can, that'll go do the thing, go search the internet, go search Wikipedia, go search Amazon and find a price for a product. Tony, you could give it a registry of all the dogs around and say, do we have a dog of this breed? Does anyone in this network have a dog of this breed? Is someone trying to trade? Let me go find that and bring that person's contact information back to you. It absolutely can do that. And all you have to say is, hey, model, if you don't know, go use this piece of code, which is the agent, to answer the question. So pretty neat stuff. Sorry, I get super derailed sometimes, but yeah.
That's amazing. I had no idea that it could do that, and look forward to learning more about it. So just really quick, one more question that we had before diving into agents was, Google also came out with its GPT version today. Are there any key differences?
Absolutely. And so Google uses, I think they're all sort of using their own sort of language models. What may be different from Google is Google has, and why some people are betting on Google long-term to win this is because they have, at this point, over 30 or so years of search data, how human beings think about answering questions. So it's trained on different data. Conceptually, the underlying model is the same. LLMs are sort of like, think about like who owns multiplication? No one really owns multiplication. But where models become different is what do you train them on? Google has obscene amounts of computing resources, obscene amounts of data, right? People are looking at Microsoft and Google right now and saying Microsoft really played a brilliant game. Their acquisition of GitHub was genius, right? Because you look at GitHub Copilot, what is that? But looking at all the code people have used in open source software, and sometimes writing code better than you can write code because it's seen some of the best code in the world. And now Microsoft has that. So when it comes to generative code, right, Microsoft's in a pretty good place. When it comes to how we ask questions, who's better maybe than Google? Google is the place people go to answer questions. And so Microsoft is one of the lead investors in OpenAI. So you could see OpenAI as like a competitor to Google. What I think and what some people I've talked to about this, the analogy I heard is like, it's probably gonna be like Coke and Pepsi, right? I think for your use case, you know, Coke is fine. Some people, Pepsi's fine. You know what I'm saying? I don't judge those people, but I ask questions. But it's the same, you know, it solves the problem, you know? And so I think that's it. I think they are used to solve the same problems. The difference is they're trained on different things, just like Coke and Pepsi have different ingredients. But it's the same thing. It's a brown fizzy drink, you know? Long term, do I think there's gonna be a winner per se? I don't know. It's exciting though. I think that's what people are waiting to see. But LangChain, this technology is agnostic. In fact, it can use, you can start using Google models using LangChain. Because LangChain, again, just uses LLMs. ChatGPT is an LLM. Bard, which is Google's large language model, is an LLM. And so you can use LangChain to interface with both of those and write applications with whichever model you want to try. And so it's pretty interesting to see how they compare in that way. So again, another long-winded answer, but here we go. Yeah, we're ready to dive back into code. Sound good? Okay. Only thing I've added so far is .env. .env is a node package for managing environment variables, LangChain, and OpenAI. And that's all we'll need to get started right now. I am going to need an API key. .env can just read any.env file on your file system found in the root directory of your project. So OpenAI API key. I'm gonna go grab my key for a second. I'm gonna make a little script. We're just gonna call this one the basics. Yes. I saw some hands earlier, familiarity with TypeScript. Oh my God, my computer's slow right now. TypeScript, basically JavaScript. nothing super crazy. We import this. What .m is going to do is actually going to find that .m file on my file system, load those variables into the runtime, so I'll have access to them. OpenAI is the model, so we're going to get open. Okay. And what's crazy about this too is this ecosystem is growing so fast. I don't know if you guys remember this last year with sort of like blockchain development. Sometimes the docs are just a little bit behind. So if I try to import OpenAI, or you try to just import just OpenAI from the root of the module, it'll actually yell at you. The preferred way now is to, in LangChain, it's a complex, not complex, but a structured module. Inside of that, LangChain is LLMs, and inside of that is OpenAPI. I'm import that. And we're going to make a async function that's going to run our code. And we'll call that. Log whatever we put out, and then we're going to catch the error. Looks good. All right, you got some stuff. I believe in running things, watching them break, and fixing them and talking through them. So I need to also install TypeScript. So TypeScript is, again, the superset of JavaScript. Some other things in here that I need. TS Node is just a way of running Node scripts with the TypeScript compiler, just straight up. Also need to initialize TypeScript. Let's see. And again, the repo has been shared. You guys don't necessarily have to code along. So I'm going to more just talk through things and code. But again, if you are coding along, have questions, I don't mind taking a pause and answering stuff. If you are feeling froggy, want to code along. And so to run this, you can just use Node. Node has a flag, the R flag, which just means require. So if you guys have worked in Node before, you know you can require modules. You can also do that from the command line. With the -R flag, it's just going to require the module before it runs your code. And this, 86, .ts. And it's going to explode because I don't have my API key. That's what I expect to happen at least. I'll let that do that. I'm going to go grab my, It's always good when things, even when things break, but you know why they broke, that's a good feeling. So it's mad I don't have my API key. So I'm gonna go grab that. I will delete that because this is being recorded. Don't want y'all getting no free Open API tokens from me. Because it is a paid service. All the demos should work on the free version of Open AI, but all right. And so now that should work. What's cool is OpenAI, unlike most things, will just read from the environment. If it can find the API key, it'll just run. So this shouldn't do anything. So just actually should just print undefined to the console, because all I'm doing is instantiating an instance of OpenAI. I'm doing that. So we'll just call this model. And we have our model. We can call it. Who gave the You ever feel like your typing just falls off when people are watching? Feel like you just call it typing, and then someone's looking at you and you trash at typing? That's me. That's me. Right. We're just gonna return this. You'll find when you use all these APIs, they are very much promise-centric. So you'll always have to use sort of async await. That's why I opt for TypeScript. TypeScript lets you use the latest and greatest of JavaScript without any of the fuss and muss. And so we can use async await. It is, to be fair, it is in JavaScript now proper, but you get all the new features like decorators, which is cool. We're gonna run this and we're gonna see what OpenAI has to say. What does it think? Who gave the speech? There's the answer. Is that right? Anyone want to verify OpenAI? Is that correct? Martin Luther King Jr. I know that's right. I don't know 1963. I think that's right. That's right. That's strong. And so that's it, right? If you wanted to put this in an application, there you go, right? In fact, we can put this behind an API. Let's do that real quick. So we can start asking an API that we made interesting ML questions. I need to install. I think I installed Express. So you guys are familiar with developing web applications in Node.js. Express is a web framework. You can do it with just raw like libraries in Node, like HTTP. I haven't done that in a while, so I'm gonna use Express. To do that, we're gonna make a little web app. So we're gonna need our .end. And while I'm setting up this code, any questions so far in that first demo? It seems, I mean, it's pretty trivial, right? We're importing OpenAI and we're calling it, right? But I guess any questions about that? Even if it's TypeScript questions or anything, I don't mind answering that either. So, oh,
Yeah, no questions. But I don't think I've ever used the HTTP library here either. I've always used Express.
yeah, it's nice. It's really great routing library. I mean, all it takes to get the app is that, right? We just create an instance of Express, add a route. It's just got whatever verb you want to use. We're going to use a post. Attach a post. It's going to be API slash AI. Fancy. And this is kind of a throwback to how Node used to be written, using this sort of callback syntax. The first argument is the route we want to expose, and the second argument is how we handle the request. I'm going to implement this, and it's going to break, but we'll talk about why that's the case. I'm going to expect there to be a question on the request body. So Express gives you on the callback function, but it's a higher order function. It's going to pass you two arguments. The request itself, so this is the question someone's asking your server, and then the response is how you respond to the question. So that is cool. We're also going to create our, I don't need to create a server. Use HTTP. This is the library P. Fletcher was talking about. Create server just takes an instance of Express, basically how it handles network requests. And so all we're doing is saying HTTP module, whenever you get a network request, TCP request, use Express to answer that, particularly when it comes to this route. Anything else, Express does some nice things for us too. It's going to throw not founds. And then we can tell it to listen on a port. 8080. And here we go. Take console. Download. See, y'all need to, when I'm coding, when I'm typing, y'all have to look away. And I won't make mistakes. But there you go. So we can run this, get our API going, and then we'll be able to test it. Yes. And let's move that now. This one, it's not app, it's API. And so should be running on port 8080. VS Code has this nice extension called Thunder Client. Oh my God. I guess I need to stop looking at the code. Thunder Client allows us to make HTTP requests in VS Code. Don't even have to leave. If you guys use Postman or any other tool like that to interact with APIs, you just have to do that. And I'm also going to add a log segment so you can see it. Twitter. And so this is just a simple Express server. We haven't even pulled in the model just yet. In fact, we're just going to copy and paste that code from the previous one, but let's just see that it works. I'm going to do localhost. Creating API AI. That's the post request. Do that. And then bam, it exploded. Okay? Because we're trying to read the body off of this. Express by default doesn't allow us to read JSON. Again, this is kind of nice. It's actually protecting us. This helps you sort of helps prevent being attacked by malicious data. You have to opt into things with Express. So we can actually say app.use. This is another feature of Express. I know we're talking about AI and ML, but we get some JavaScript in here too. Can't help it. Gotta have it. So now it should be able to listen to the request. We can actually log our question or basically echo our question. Like that. Well, let's see this work first. Then we'll do some stuff. Like that again. I think let's change this with it one more time. And we'll hit the endpoint and see what's up. Okay, we got our response. Very cool. Again, simple server. You know, again, we're not talking like a lot of code in either of these instances, right? To pull in the model, 2 lines of code. To build a web server, less than 20 lines of code. Even to add a model, let's just add the model. We'll get some logging in here for Express so we can see everything's happening. We do app.use. Again, Morgan is a middleware, just like a nice logging convention. So whenever a request comes into our server, we'll get noise, some chatter about that. And then, of course, we're going to need OpenAI again, a link chain. That's IntelliSense helping. We actually want to do model. One thing you might want to be cognizant of is when you do instantiate this or create an instance of OpenAI, you don't want to do it inside of a handler. Why is that? Because one, it's an API that throttles you, so you can get their API will block you from using it repeatedly. And creating an instance of it is a network request. It has to use your API key to request credentials from OpenAI's server. And so you want to instantiate or create an instance of the model outside of OpenAI. Okay. We will introduce this concept called temperature. Temperature. This is a new one. Temperature describes almost how much variation the model can use in answering a question. If you're trying to do something that's very much question answer, in other words, it's only going to answer questions literally as it has the answer, you want to have a low temperature. Something with high temperature, like 1, means you're saying the model can just basically make stuff up. So when you're creating your models or creating an instance of a model, you want to have a lower temperature. Okay? And so now we can take our question, we can get our response. Response. Model. Okay. Our question. And then we can respond back with our response. And that is an API with an AI endpoint. Now, well, let's actually test it, see it, make sure it works. Who's the president? So you're going to figure it out. There's a lot of presidents out there. I wonder if it's just going to assume the US. So what we did, just a quick recap, is for our model is 1, we had to make sure our environment was set up with the credentials. So we needed to use .env to load in our API key. We're using HTTP module and Express and Morgan to create our little web server. And then we import OpenAI from the large language model submodule from LangChain. We instantiated it, did the same thing with Express. We told Express to use JSON, told it to use logging, and then we defined a route. This route takes a question, as JSON, poses it to our model, and returns a response. That's it. But let's see. Let's see. Respond. Nada. Oh, I need to wait. It's async, like I said. Sometimes you play yourself. Play myself. Let's try one more time. Same question. He is number 44, Barack Obama. Pretty cool. So what we just did was we took OpenAI, we wrapped it in our own API, and now we're asking it questions. And so there's nothing stopping you from today using ChatGPT, even without training it on your own data, to answer questions for you, right? Imagine being able to build a web bot. You could easily put this behind, again, a web server and have something that can answer questions for your customers about things about your business. And we'll see in a second how to give it actual data, right, that we have, and let it answer questions with that data, okay? Pretty neat. But any questions so far? I mean, this is all pretty, again, like we saw the basics. This is just the model itself being imported, being used. We use this method called call to answer questions. And then the express stuff is kind of ancillary. This could work in anything. If you use Fastify, you use like the raw HTTP module. Just put it behind a web server, and now you have a model in your API. Okay? Pretty neat. Questions?
That's awesome, man.
It's pretty cool, man. It's pretty dope. Excited about AI. It's taking my job. So yeah, let's build a QA bot. What data are we gonna give it? Ask it some questions. Why don't we give it the? Let's put it up. I'm gonna give it the Black Codes newsletter and let it answer questions from the Black Codes newsletter and see if it can parse this and give us answers. So we're just gonna get this text. It won't be able to do the video because it doesn't have the ability to. I mean, we could make an agent probably that could go to YouTube, play the video, get the transcription, do that. But we'll just give it the plain text for now. The beta folder. This the see whatever. CST. This is plain text. Copy and paste from the newsletter. And we're going to build our QA bot. Some of this stuff is copy paste. We can get our API key in there, and we're going to need OpenAI. And we're going to need our async function. It's going to know how we run things. We need to load in this data. And so to do that, we're going to have to pull in other parts of LangChain. Do that for us. For example, LangChain ships with, like I said, you can take data from anywhere, and they have some ones pre-built for us. There are these things called document loaders. And so LangChain has a few data types. There's the data type, which is the prompt. And so this is how it takes questions. There's documents, which are those text things that we generate embeddings from. Embeddings is another data type. Vector stores, and then, of course, the models themselves. The document loaders come in a few different varieties. So this is the file system one. It can load documents from buffers, which is just in-memory representations of data, docx, Notion, JSON, unstructured data. We're going to use plain text because that's what we created here is a plain text document of the Black Codes newsletter. And this is called the text loader. They are documents. It's a new text loader. The way they work, it's kind of like, I don't know, Java-y. It's not like a fluid API. If you guys have used like D3 or jQuery, there's a lot of classes that you use. Because this is really written in Python first, and so some of this might even look weird for JavaScript developers because we're using a lot of classes, but it works. This takes a path. You haven't worked with paths in JavaScript. One interesting gotcha is that the path that it runs from is not the path it needs to pull our documents from. So I'm going to import path from path. Path is just a utility library built into Node.js. Say text. Resolve. Now this is our current directory, and then I can give it a relative path to our data. BBC news txt. Text path. And we're just going to return the documents. This is going to log, so we're going to look at what that looks like actually. Again, different script this time. That's what we can see. It's like this. So what we expect to see is just LangChain loading in our data and giving us back a document. Document is the data type that it needs to process this data. One thing that's interesting that we touched on very briefly is just the relationships between data as they're defined in vector stores. They're embeddings, okay? So embeddings, what they need actually are ways of chunking up our text into meaningful bits. So if someone tried to give you just a sentence, right, and just gave you a word, and they say, well, what do you mean by blah? There's usually not enough information there. And it's true for models too. We actually have to chunk up our text into meaningful pieces that the model can actually learn relationships between those words. And so LangChain also comes with this thing called a text splitter, that we need to split our document into smaller bits. So split document, and use recursive.
Is there a character limit on that?
Character limit? Yes, that's actually true. And so these documents can only hold so much in memory, right? And then even the models themselves, I think the character limit is something like 11,000 or so characters like you can give to ChatGPT. Have you ever tried to just paste a big old document in ChatGPT? It's just like, yeah, bro, I can't do that. That's too much. Man. And so you have to be able to chunk it up into smaller bits so that it can reason about the data appropriately. And so this text splitter allows it to sort of process data in those small, meaningful chunks. And so we can do text splitter, recursive, text splitter. And what this takes is a chunk size. I've messed around with this a little bit. This is one that you might mess around with yourself. And then chunk overlap. We'll see what that looks like. Documents. I guess some documents. And this is, I'm sorry, I'm going pretty fast right now. But this is one of the cool things about TypeScript, right? And so we're actually getting not only type completion on this, so as I'm learning the API, I can put my cursor over things and I can get meaningful errors. It says, oh, it takes a record of string and documents, returns a promise. You know, TypeScript gets some flack because it's not necessarily the prettiest thing to look at, but once you appreciate sort of what it's trying to convey, it's kind of nice to have that level of feedback in your code of saying, oh, I am missing an argument here. Yeah, I said split documents, but I didn't pass documents. Well, let me pass the documents.
It's classic Microsoft. It's not pretty, but it's powerful.
Ooh, tell them about it. And respect the Microsoft, man. And so we're going to get the split documents. Take a look at that. What does that look like? It's going to be very similar to this. Just a whole bunch of little tiny chunks. And so, again, why we do this is the model itself. And so you see some overlapping. This is important. Why the overlapping is important is because it actually allows us to sort of This is an algorithm under the hood called chi-squared. What chi-squared is doing is based upon just relationship between repeating phrases, understanding how likely it is, we talked about probability before, that a subsequent word will come next. And it does that basically by allowing the text to overlap one another and just see how often it is, even in overlapping sentences, that a word will occur next. And so that's a very important part of how that works. Next we need, and this is maybe why the Python library is a little bit nicer, but we'll do it anyway. We'll do LangChain vector stores. Lib. This is an important algorithm for actually navigating what are called vector databases, vector stores. Hierarchical, navigable, small world algorithm, HNSW. Crazy word. Hierarchical, meaning things are stacked upon one another. Navigable, in other words, it's easy to sort of relate vectors to one another. And small world, which is an algorithm for distance between two vector points. We need that so we can actually give it a vector store, like we said before in our handy dandy drawing. We can give it our embeddings, right? And from that, we'll be able to ask it questions. And so it's a lot of maybe dense code. I don't think it's a lot of code, but there's some, it's getting a little thick in here. Code getting a little spicy. We with it. We with it. Store. Embeddings. So we talked about embeddings. How do we generate embeddings? Like I said, that's something we don't necessarily have to worry about. LangChain and OpenAI does that for us. So we can do LangChain, embeddings, OpenAI, and we can import OpenAI embeddings. And it'll actually generate those fancy things for us. OpenAI embeddings. Oh, you know what? Let's We're going to give it our dots, our split dots, and our embeddings, which would be the instance of the new OpenAI embeddings. This is, again, asynchronous. So this is going to give us back what we need. We're also going to get our model. We need to do a rate. Some chains. Another useful library. LangChain. Chains. I got chain. So these are, when we talk about pre-trained models, this is an example of one. This is a model that's been already trained. The retrieval Q&A chain is one that can answer questions based upon data. And so what we've done so far is we have loaded our text. We have split the document into multiple tiny chunks. We've actually added it to a vector data store, okay? So what the store is, again, is that sort of collection of embeddings that the model can then use to answer questions based upon the similarity of the text in our question to the data that it's been given. Now we actually need to have a model that can make sense of that question, okay? So what that looks like, my computer's struggling right now, struggling. So we're going to need to take an instance of OpenAI again. And give it some temperature. We don't want it guessing. We want it to be legit. It's going to take a retriever, which is going to be our store. That is. And so, what this is, that's not a promise. Is there's some shadowing going on. I use the name model. That's why I was mad. But now we have our model, and now we can ask it some questions. And so, essentially, what we did is we took our vector store. We can give it to this chain, which is, again, LangChain's way of composing multiple models together to answer questions, but it needs a way of understanding how to get data from the vector database. And so that's what this store is that we created. That algorithm, crazy name, hierarchical, navigable, blah, 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 whatever. It's just a way of actually relating embeddings to one another. And now we have our model, and we can ask it a question. So, man, took a second to get here, but I promise. It's cool because we gave it the newsletter, and now we can ask some questions. Let's see. Who is the moderator? So let's see if it can answer this question. So in the newsletter, we mentioned a talk being given, and then we said there's going to be a moderator. So let's see if the model can answer that. Probably shouldn't have done it this way. I probably just should have seen if it ran first. We're not getting on hype. If it break now, we're going to be disappointed. Let's see what's happening. Who's the moderator?
And while this is running, Warren, I have a quick question, 2 questions. So first question is, well, I know that we just fed it information. You know, we gave it the information or the text file from the newsletter itself, but did I hear you say before that we can, as soon as you've got it up and running, we can go ahead and start asking it questions because it's connected to the API? Or do you need to feed it information first?
Yeah, so there's a few different types of models. There is just the OpenAI one, which is, again, been trained on time immemorial data. It can answer just general questions, period, right? This one, we had to train it. We had to give it data. So you can still use this model. You can write code that can, basically, we could put this behind an API. So there's nothing stopping the black codes from taking all newsletters we've ever had, right? Feeding that to this model, putting it behind an API that people can go and ask questions. And the model could then, via the API, answer any question people have about, well, what's happening on May 11th? And the API will just answer the question based upon the newsletter. But see, that's like, so now I'm getting hyped again, I'm gonna have to calm down. But what I think is so cool is like, we can just write things in human language, give it to the computers, and the code just works. It just goes. You know what I'm saying? Like, you don't have to write this. You just write the newsletter description as you would, give it to the model, and now an application can answer questions about it. I think that's just so phenomenal. So yeah, I guess, I don't know if that answers the question or not. I'm sorry.
It does definitely answer the question. Just another on topic but off topic question. Someone asked in the chat, how do you see AI changing tech jobs such as programming?
Ooh.
So you got it.
I got to pull up one of the demos from the sample repo, but there are people right now who are non-programmers having ChatGPT write React applications, saying, I want a component that does this, and it should have a login page with the logo. This is my logo file, by the way. Put it here in the top left. And it should have user auth for this kind of like auth 0, auth. Here are my API keys. And ChatGPT is literally writing that code, and they're just copying and pasting it from ChatGPT into the code base, and it runs, it works, you know? Do I think that's a danger for our jobs? I don't think so. We talked about this before, just in the black codes. Your job is probably safe because it takes understanding of the problem, you know? Like, nuanced understanding of the problem. Because the person who's describing this React app, they know their problem, but the computer doesn't know. You still need a human being who can articulate really the goal of the model. So as long as you're a problem solver, I think you're always going to have a job. Do you have to remember all the syntax? No, you don't have to remember. Like, how do I set up a Redux store? How do I add Tailwind? How to do that? Don't remember that stuff. Have ChatGPT do that, but you are the problem solver. You know, use that higher level of thinking. But I don't think you have to remember syntax anymore. You know, I think that's the answer.
Yeah, I think it's just going to make interviewing harder. And I think they'll implement more and more, kind of like you know how you might take a test and you got to do it in front of the camera, and you know, and they want to see your face. And I think it'll make interviewing harder, and they'll just implement more of those things where they can watch you, make sure you're the only person in the room, make sure you don't leave the screen, make sure you're not over here texting, you know, on your phone trying to find the answers. So, but yeah.
Totally see that.
Someone added, wouldn't it also depend on the industry as well, such as healthcare, finance, entertainment, etc.?
Yeah, like whose job is in danger? I think programmers, again, probably fine, like tech workers for the most part. There are whole businesses that are being erased right now because of this, like Rocket Lawyer. I don't know if you guys know that company. They're the company that you can just go and have it make legal documents for you. Just their share price bellied up overnight. They're filing bankruptcy. They just don't have a need, because it's just like you can literally go to ChatGPT for free right now and say, I need a contractual agreement between myself and a tenant as a landlord, and it'll generate one that'll hold up in court. What do you need Rocket Lawyer for? You know, when you can do that stuff for free. These bots can do incidental findings in like healthcare. This is like when you look at imaging from like x-rays and say, is there sign of like metastasizing like tumors or something? Bots are doing that, and they're writing better notes than the attendings sometimes, right? And so a lot of that clerical work, that sort of like mindless typing stuff we used to do, I think over the next 10 or 15 years, it's probably going to go away, like honestly.
Lance, I see you've got your hand raised. Do you want to go ahead and step to the stage and ask a question?
So it's a little comment about, so for industries as well. So we'll still need humans, because I think of healthcare, for instance, like writing queries to help like diagnose something. What we forget is that there's still some bias with AI, and especially when you think about African Americans and health, there's natural bias that goes with that. So there's going to be need for humans, because you don't want the AI to predict someone's health based on what they know pretty much that's out there in the universe, like from the information they're getting fed. So there's still going to be need for humans to like kind of filter that out.
Yeah, for sure. I'm a little of the radical bend, so I'm with you 100% when it comes to data integrity, data correctness. You know, I think we absolutely need a world where, as African Americans, we just know this data isn't trained on us, right? And so we have to be advocates for ourselves and saying that, you know, if a model is being used anywhere in my treatment, I need to know what it was trained on. And if it doesn't have equal representation of Black people in that study, don't use that model on me. And we should be that persistent about it. And until we are, they're going to continue to use models that have been normed on white patients and try to apply that to us. We talk about reproductive rights right now. This is just so pertinent because of Roe being overturned. The mortality for Black women, people like my mama, you know, my sister, it is 3x that of their white counterpart. The same age, same health, you know, well, health markers. We're still more likely to die giving birth, you know? And these models are going to play a role in how people are treated. And so I think we absolutely have to be advocates for ourselves and say, yeah, if this model wasn't trained, equal number of Black people as you are training on white people, you don't get to use it on me, you know? I don't care if it costs you more money. You need to save my life. You know, you need to take care of me. And that's just something we need to be, advocating for.
Thank you.
Thank you, Lance, for your question. Dooley, we have another question for you, Warren. Dooley just raised his hand. Did you want to step to the stage and ask it, or you pop it
Yeah.
in the chat? Thank you.
And that's one of the things we're leaning more towards an ethics issue, and that's probably one of my greatest concerns as far as it goes to artificial intelligence. And I'm pretty sure I'm not the only one that feels this way. In regards to how do we police these things? You know, how do they get out of control? I personally feel that it will come down to robots making a decision on who will live and who will die. I think that's pretty much, it's been put out there in the ethos, the ethos of conversations and discussion on where technology is driving. And once again, it's all about the eye of the beholder, who's actually controlling this technology, who's policing it. I actually had a dispute with ChatGPT, and it apologized to me when I logged back in because it was incorrect. And it was, I don't want to get too far into what the discussion was about, but it was one of those things where it was like, I knew that there was factual evidence in regards to information that was released, government related, FOIA, Freedom of Information Act information. I brought that up after it told me a general answer of what was already kind of out there in mainstream media. And it kind of corrected itself and then came back with, I'm sorry, we don't know any, we don't know everything that's current. We're just an AI model, blah, blah, blah. I was like, okay. And now I'm like kind of nervous to use it right now because I'm like, people are feeding this information of what is general consensus, what's popular, what's out there. So it's like whatever's out there that you can have access to is what's being fed. But at the same time, a lot of that stuff is questionable because of the sources. So, and I'm just leaning, like I said, ethics is going to be a huge thing as far as it goes to this. I mean, we know what computers do. They spit out what you give them. But that's my greatest concern. But the question would be, where do you think things are going in regards to that, and what measures are there that's being discussed as far as it goes to policing it?
Yeah, you guys saw, but there is a Democratic sort of House committee asking for like an all pause on AI development until Congress has a chance to sort of understand and weigh in on the implications of this. I think that, I don't know if that's ever worked. I know you guys have seen the hearings when they bring in, TikTok CEO, Facebook CEO, and they're asking like, how does Wi-Fi work? Like, our politicians are not equipped for this type of stuff. I think Jernell, he's great about this. Like, think about Civic Hacker, think about some of the things that they work on. I think we have to start that here. We can go to our Congress people today and say, as Nashvillians, as Tennesseans, we want our data to be protected. If my data is being used as a Tennessean, this is what they're doing in California. That's the California Data Protection Act, right? We're saying that if our data is being used, I should be notified of that. And then if it is something, for example, like there are companies who are using this to determine mortgage rates, models, right? And what is, Tony, this is the name of the black codes. You know this. Y'all know redlining. Is there data on us as owners? Can you do that on historical data? Can you say what a black homeowner is, the same definitive, or I guess, I don't know, all of that inference, can you say that fairly when we know the system itself was designed against us? You can't, right? And so unless there's someone in that room, probably one of the people in this room, in that coding conversation saying like, yeah, no, that algorithm's racist as hell. We need to be part of this conversation. And so to the point of where it's going, I hope we start to see, I'm sorry, unfortunately where I see it going is it probably is a state that puts some sort of law in place to protect its people's data. There'll be an infringement upon it. It goes to Supreme Court. Supreme Court now being probably the most conservative it's ever been. I'm not saying that's good or bad. I'm just saying it is what it is. It's probably going to be pro-business. And until there's enough sort of ire and engagement consistently from the voting class on this issue. And then we have to spend money on it. I think we need to find companies. We need to create companies that are advocates for protecting data, and we need to use them and engage in them. Because otherwise, it's not going to happen. We are a capitalist society, for better or for worse. And so it's where the money is. And right now, the money, of course, is in firing workers, replacing them with bots. And so until we make it as profitable or as meaningful to protect data and to bring ethics into the conversation, I think capitalism's going to be capitalism, unfortunately. Or fortunately, I mean, whatever. I think basically we just need to be aware of it. I think as Black people, we can profit off of it. It's not always the case. We tend to be exploited by these things. So yeah, but I could, man, I feel like Dooley, I feel like you and I, we could talk about this for like hours, man. So.
For sure.
Mm.
And thank you very much, Warren. I appreciate that.
Yeah, absolutely. Data is more valuable than oil. Data is the new oil, man. I'm sure you heard that. They say it's the new oil, new electricity. Data is it. It doesn't get more valuable. But I think our model's good. I think we can ask it some questions. I think we can see what it has to say. I guess any more questions before we do the big reveal? Can it answer? Who was the moderator of the event? Can it do it? Oh, drum roll. Drum roll. Let's see. And there it is. And knows it was Kanisha.
Amazing.
So we gave it the newsletter and we asked it a question. Let's see, let's look at the newsletter a little bit. I have it put up. Do it down there. What's a question? Yeah. What did Serena Williams watch? See what it says.
Chris raised a valuable point that I didn't think of in chat. Chris mentioned data can pollute too. What are your thoughts on that? On data pollution or oversaturation of the data?
Yeah, Julie touched on it too. It's just this nature of one, I think we've decided that truth as a country is arbitrary, right? That was the whole thing with the 2016 elections of who can say what. Fox recently lost a big lawsuit about Dominion voting machines, saying that they are broken and compromised the election. They had to pay up in the court of law, but no one is speaking to the fact that Fox in that hearing said, yeah, we play fast and loose with the truth because it sells. And this is the very same data that these models are being trained on. And so to that point about pollution, we're getting into a place with this data, particularly if it's going to be it's not the arbiter of truth, but is the purveyor of truth. It's the one selling it and peddling it. Someone has to be accountable to what is designated as truth in this world. We talk about hallucination in models. It doesn't know, right? It knows what it's been told. And so how do we start to clean up the internet in a way, just like we live, like you said, with pollution, and say like, no, this is fact, you know? I think we can do that. I think that gets in a very interesting place because conceptually, this is why tech is so cool, man. We're talking about philosophical stuff, and this is deep. But it's like, who gets to decide what true is? You know, that's the interesting thing. We have it being taught in schools right now when they say we cannot teach critical race theory. First of all, you don't teach critical race theory. We know people tripping. It is fair to say that there is a lens you can look through history and say it is disproportionately affecting African Americans. That's a legitimate statement. I think you could do the same thing for any minority group. But we'll leave that there. I just think we're in a world right now where it's so political to talk about what the truth is, and these models are just caught up in the mix of it. And so they're only going to reflect us and our bias and our polluted sense of the world. And so, yeah, I think unfortunately, infodemic. Come on, Lance, come through. Man, he said there's a new oil. He got the infodemic. My man is about to drop the hottest AI mixtape. the world has ever seen. That's gonna be clean. Dang. But yeah, and we can wrap up. I know we're coming on time. It does know what Serena Williams is launching, but we should ask, what should we always remember? Let's see. You patented. Should be.
Tony, you have your hand raised. Step on to the stage. Lend us your thoughts.
Sure. Well, I actually have a question. Now, how can you take this data and make it like a word cloud?
Word cloud? There is this really great node library.
Don't test Warren.
Ooh, come on, man.
Oh, this is not a test. This is yeah. Warren know where I'm going with this.
But
I'm just over here cheesing.
that's fire, man. These libraries are ridiculous. But Tony, there's this really great library after we talked called Wink.js, and it can generate what is called a context-aware word cloud. And so even just given the plain text doc, I mean, she will do a live. I ain't scared. I'm scared. It looks like it just takes an array of documents and generates your word cloud. In fact, it even highlights it inside of the source text, which is pretty cool. So I'll send you this thing. This is
Yeah, please. I was gonna say, yeah, please share that link.
absolutely fire for conversations with stakeholders when they can see their data. Data is just empowering. It's the new oil, you know. Oil has been used to build civilizations and crush civilizations. We see what it's done to the Middle East. We see how it's made us rich. Data is the same way, you know. And there's something about being able to see it that changes the way we think about it. So us getting data skills, I would say, like, if there's any takeaway from this, I feel like as engineers, we have to think even beyond front end, back end, full stack. We need to be technologists, period, you know. So we can think about the data. We can think about we can think about all these things. That's how we really liberate ourselves in this moment. Because if we're just seeing the front end, we're only seeing one half of the story, you know. And so I hope this demo, maybe like you see how tractable some of this stuff can be, you know, and just like Calvin says, what should we always remember to do? Even ChatGPT knows, man. It's stick to the code. So appreciate y'all. But any more questions, we're definitely open to talk about it.
This has been wonderful. Yeah, we're getting so many accolades, so many kudos and words of encouragement here in the chat. Thank you again, Warren. This has been so informational, insightful, and I don't know where anywhere everyone else is going to go with this information, but I'm thinking of the next moves. Like, for instance, you know, how can we QA what we're doing right now, and will we need to QA the open AI ourselves? How can we incorporate this in just our day-to-day, you know, life as far as tasks? And then I'm even thinking about like the agents and how you can chain them together and continuously just build on to this chatbot or this bot. There's a lot of information that you just dropped. And I know someone's going to take this and run with it, you know, and build something unimaginable with it. So again, thank you so much for taking the time out to explain this to everyone, to share your knowledge, your thoughts, you know, where it's going to go in the future. Just thank you again. Does anyone else before we leave have any other questions or want to step to the stage and say anything to Warren?
Yeah, you can just insert my name in that statement you just made. Tony's gonna take this and go do something. No, this is amazing. Thank you so much, Warren, for this. It has opened my eyes and have given me a new set of tools to go play with and to make Social Dog great. So I appreciate it so much. Thank you, sir.
Yeah, Warren.
Mr. Miyagi of data.
Real quick, Khalil want to know if he can, is it possible to get the slides as
Just
well?
dropped a link to the Canva.
Okay.
Yeah.
Okay.
Yep, that's the last link in the chat there. So he's posted that link there. If you have any questions, be sure to reach out to me on LinkedIn, or I'm sorry, Warren, but reach out to Warren as well on LinkedIn if you have any questions, or also in the Black Codes if you are in the Black Codes. Thank you again, everybody, for joining in. It's been a wonderful time with you, and we look forward to doing something like this again in the near future. Take care and stick to the code, everyone.
Peace.
Stick to the code.